Hey guys, it's Miss Adams, and we are looking at the Unit 10 test review. So Unit 10 is all about data. So we're going to be using that data button in our calculator to kind of look at some of these measures of central tendency, look at our 5-number summaries, all of that jazz. So the first question says, use the data below to determine the measure of central tendency and dispersion. So we're given the list 12, 9, 5, 9, 3, 1, 5, 5, 5. We could do this by hand, but we've got the data button in our calculator. We're not expecting you to do this by hand. So I'm going to go ahead and hit data. I'm going to hit it again. And if I hit number 4, I can clear out all of my data lists. And then I'm going to enter in each term. So I've got 12, 9, 5, 9, 3, 1, 5, 5, 5. And since this is a single list, it really doesn't matter the order that I put them in. I then can hit second data. I'm going to do one variable statistics, and I'm going to have it calculate it. When I'm looking for the mean, I'm looking for that X bar. So X bar in this case for this set is 6. Then I can scroll down to find my median, and my median is 5. And the only one that's not going to be given to us from the calculator is our mode, and that's because it is whatever occurs most often. And the only number that occurs more than 2 times is the number 5. Now for standard deviation, we're either going to ask you about the sample population or the entire population. So if I were to look at the standard deviation for the sample, I would say that S of X is equal to 3.39. Or if I was looking for the entire population, I would say that sigma X is equal to 3.20. We will identify which standard deviation we would like for you guys to give. So let's go down to number 2. Number 2, this is an application problem. It says the table below shows the hourly wages for the workers at the pharmacy down the street. It says go ahead and find the mean and the median. And guys, even though this is listed as money, you can still put it into your data function in your calculator. So I've got 8.25 after I clear out my list, 7.5, 8.5, 7.8, 14.5, and 55. Now, I would take this a step further probably and be like, is there an outlier? And if you're looking at that, the pharmacist does get paid quite a bit more than everybody else, but let's see what this does to our data. So I'm going to hit second data, go to a one variable statistic, and calculate. So my mean in this case is 16.925. I'm going to say 6, and you know what? Because it's a terminating decimal, I'm just going to go ahead and put the whole thing, 16.925. And then my median is 8.375. And the math teacher in me says, let's take this a bit further. Because we do have an outlier, we could calculate the outlier using the lower fence and upper fence. But that 55 is reasonably to say that it's an outlier. I would use my median as the measure of central tendency here. So if I'm looking for the predicted wage of these workers at the pharmacy, I would eliminate that outlier and I would say everybody makes around $8.38. So now let's go and see how I could apply this when I'm looking at 2 different sets of data. So it says use the data and box plot given, calculate the boundaries for the outliers for both the male and female data. Correctly fill in each blank according to the statistics you found. So notice it's already calculated our measures of central tendencies for us and our 5-number summary. So we're given a median, a minimum, a maximum, the Q1 and Q3, and the IQR for both male and female players in this case. So we need to calculate the lower fences for the males. So in order to do this, I'm going to take the Q1 for the males, which was 62, and subtract 1.5 times the IQR for the males, which is 16. So I've got 62 minus 1.5 times 16. This means my lower fence for the males is at 38. And I'm going to calculate the upper fence for the males by doing 78 plus 1.5. So 78 is that Q3 value plus 1.5 times 16. So 78 plus 1.5 times 16. And that is going to give me 102. Lower fence for females. So I've got 50 as my Q1 for the females, minus 1.5, multiplied by 30, which is the IQR for the females. So this is going to give me the number 5. And then the upper fence for the females, I've got 80 plus 1.5 times the IQR for the females, which is 30, which gives me 125. Now, I need to look at my minimums and maximums. The minimums for the males was 30, and I've got a lower fence at 38. So this might cause me some issues because I've got a minimum at 30, but I've got a lower fence at 38. Maximum is 90, and I've got a upper fence at 102. And then for my females, my minimum for the females was 36. I've got a lower fence back here at 5. And the maximum for the females was 98 with an upper fence at 125. So all the data for the females is contained within the fences. But for our males, we do have an outlier of the minimum, which is 30. So there's none for the females. Guys, you look at your minimum and maximums to see if either of those values is an outlier after you've calculated your fences. All right, let's go to the next page. So which set of data has a greater spread or variability? Well, let's calculate them. So I'm going to go data, clear out my values. I'm going to put in set 1, so 2, 9, 3, 17, 14. And I'm going to go second data and do one variable statistics. For my first set, I'm going to use purple, and I'm going to say that set 1 has a mean of 9. And I'm going to say that it has an S of X. It says 6.595 in my calculator, so I'm going to say 6.60. We can also look at sigma X. Why not? So the entire population is going to have 5.899, which is going to round up to 5.90. Then set 2, I'm going to use pink. I'm going to go ahead and clear out that data and put 20, 15, 16, 19, and 15. I'm going to hit second data and do the one variable statistics again. I get a mean of 17. I get a sample standard deviation of 2.345, which is going to give me 2.35. And I get a population standard deviation of 2.097, which is going to give me 2.10. So if I'm looking at which set has a greater spread or variability, the one with the greatest spread is going to be set 1 because our deviation is larger. All right, that gets us to our socks, and I'm not talking about the crazy things I wear on my feet. We're talking about the graph below. So it says identify the shape, outlier, center, and spread. So most of our data is concentrated to the right-hand side, which tells me we may have an outlier to the left. Notice we have a higher concentration of data on that right, like I just said. But we do have this little bit of data on the left, which means I'm going to be skewed to the left. That means there is an outlier since it is skewed to the left. Anytime we have an outlier, we're going to switch to using our median and our IQR, so everything in that box for the box and whisker plot for the shape of the data. This kind of it eliminates any of those outliers within looking at the consistency of the spread. That leads us on to problem 6. So problem 6 says the 5 number summaries below show the travel from Storybrooke to Quahog on a bus and a car. Construct a box and whisker plot for each bus and car on the same number line. So we're going to use the same values for this number line. This was something that was missed quite a bit when we did our quiz. Let's go ahead and make our number line by tens. So I've got, or not by tens, I apologize, but twos. So 2, 4, 6, 8, 10, 12, Sorry about that. $14, $16, $18, $20, $22, $24. I'm actually going to wind up going off for the maximum. So what I may do is just start at a little bit different number here. I'm going to start at 10 for this one just to make sure everything fits. So I've got 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, and we'll throw an 8 down here as well. And then for the car, we're going to do the same thing. I've got 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. And let's go ahead and plot this bus one first. I've got a minimum at 12. Q1 is at 15. Median is at 17. Q3 is at 22. And a maximum at 32. And then if I look at the car, I've got a minimum at 8, a Q1 at 10, a median at 11, Q3 at 13, and a maximum at 17. What we really want to identify here on the bus graph, so we're looking at this graph, what percent of the data is in between 22, which is here, and 32? Well, that is just 25% of the data. On the car graph, what percent of the data is in between 10 and 17? So I got to look at my car graph, which is up here. I've got 10 and I've got 17. Well, that's 1, 2, 3 of my quartiles. So that's going to be 75%. And it says complete the SOX for the car. So we're looking at this one here. Is this symmetric or skewed? I would say it's pretty symmetric. So there is no outlier, which means we're going to use the mean and our standard deviation to find the shape, outlier, center, and spread for this data set. And guys, that gets us to the end of the second page of the review. And we've only got, I think, only one more page, 2 more pages. So let's go ahead and knock them out. It says label each scatter plot as either linear, quadratic, or exponential. This first one I would say is pretty linear. Looks like they're all somewhat going in a line. Second one I would say is exponential due to the curve. The third one has a parabola, so this is a quadratic. And the last one does have a line as well, so it is a linear set of data. And we're going to guess on this next one. It's not going to be perfect, but we are just guessing based on what's given to us. It says we have 5 scatter plots that have different R or correlation coefficient values. Place a letter for each graph in the ascending R values from -1 to +1. So first off, I'm going to go ahead and find -1 and +1. C has a pretty straight line going down, so I'm going to say that that is my -1. As X increases, Y is decreasing. Correlation coefficient. So I've used this graph, which is good. I'm going to say that D is going to be as close to +1 compared to the rest of these as possible. Then I'm going to go in ascending order. If I look at E, it's not super strong, but I still do have a negative correlation here. If I look at B, I have a positive correlation, but it's not super strong. And A really does not have any correlation whatsoever. That leads us to problem 11. And so we're looking at this, and they're running an experiment to show how much sleep she got before a big test to see how it would affect her test scores. So the scatter plot shows the hours of sleep she got and score on a test that you took the next day. So we're going to write an equation of best fit. In order to do that, you're going to go to the data function in your calculator. And now we have our X and Y's. We got to keep these in the same order. So I'm going to go 1, 1, 2, 2, 3, 4, 5, 5, 6, 6, 7, 8, 9, 10, and 10 for my list 1. My list 2 is going to be 1, 1.5, 2, 3, 3.5, 4, 4, 5, 5.5, 6, 6.5, 8, 7, 6.5, and 8. So I'm going to hit second, data. And now I've got two variable statistics. X data is list 1, Y data is list 2. And each of these only has one frequency. In order to write my line of best fit, I've got to have Y equals AX plus B. So in this case, I have Y equals my A value for this set is 0.696, so I'm going to say 0.7 X plus my B value, which is 1.10, I'm going to put it as 1.1. And then my R value, which is my correlation coefficient in this case, is 0.95. This is a positive, strong correlation. Okay, so which test score would Yadira get if she slept for 8 hours according to your line of best fit? Well, we're going to plug that into the function. I'm going to have Y equals 0.7 times 8 plus 1.1. I got 0.7 times 8 plus 1.1. This gives us 6.7. But look, it says in tens, so this is going to be approximately a 67 on the test if she got 8 hours of sleep, according to the data. Now it says label a graph with the following vocabulary terms. It says bimodal, unimodal, or uniform. Bimodal means it's going to have two areas of most frequency. So our middle one is our bimodal. Unimodal means it has one area of frequency, so this is unimodal here. Uniform means there's really no mode. So the last one would be uniform. Last but not least, we're going to talk about correlation versus causation. Causation means you actually have a cause and effect. So you lied to your parents and now you're grounded. You did something wrong, so this is a causation. The number of hours worked and the money made. Well, the more you work, the more money you're going to make. So I would say this is a causation. A child's weight increases, so does her height. This is not always the case. So I'm going to say that this is a correlation. The temperature outside and the number of people selling ice cream. I also say that this is a correlation. And Becca noticed the more people went to the grocery store on Mondays and Fridays. This is also just a correlation. All right, guys, that is your Unit 10 test review. Let us know if you have any questions.